Yeah, welcome viewers to our today's topic and subject. I want to welcome you at home there, the candidates, the viewers, and even the parents. Stay tuned to KUTV as I'm going to take you through in this lesson. Today, I want to discuss about energy transformation. In the first thing, before I do that, I want to tell you that my name is Mr. Chris Omondi from Koradini Catholic, Utawala. Stay tuned and welcome. So today we are going to discuss about energy transformation in science. Science. The topic is energy Then a subtopic that I'm going to take you through, just be patient for the candidates. If you have a pen and a piece of paper, it will be of value to you as you prepare for KCPE 2020. So the subtopic is energy transformation. Energy transformation. Energy transformation. Today is on 14th 5 2020. So I first want to discuss about energy. Then I'll have to bring you into what we call the energy so that you understand what we mean by the word energy and what are these energy, what are the types of energy, forms of energy, and also energy transformation. The first, energy is defined as ability to do work. Energy is defined as ability to do work. That is energy. There are so many definitions which as well when you approach the examination, it can confuse you. I'm saying energy is ability to do work. Energy is the ability to do work. That is the definition, not ability to work, ability to do work. Then, energy, it is what we use to perform our various duties. We need energy to work, we need energy even to eat, we need energy to till the land, and we need energy even to run. So when I talk about energy, it is what drives us and what makes us to perform the daily activities. So energy is measured using the units called energy units for measuring energy. It is measured in joules. It is measured in joules. That is kilojoules. Energy is measured using the units called joules. Now, after saying that, I want to let you know that we have different forms. We have different forms. Let me write here. Forms of energy. Forms of energy. We have different or various types of energy, or energy exists in various forms, and this is not the sources of energy. It is electricity is a source of energy, but I'm talking about how or in which form does energy exist. The first one is light. Number 2 is heat. Number 3, magnetic. Number 4, electricity or electric energy. Electric energy. Number 4, sound energy. Number 6, sound energy. Number 6, we have light energy, heat energy, magnetic energy, electricity or electric energy, sound energy, chemical energy. Chemical energy. Number 7, mechanical energy. When I talk about mechanical energy, it is the same as kinetic. Kinetic. This is the energy in motion. Kinetic is the energy in motion. Kinetic. Kinetic, sorry. K-I-N-E-T-I-C. Kinetic energy. This, we also have another energy that is called potential energy. Potential energy. Potential energy. I hope this one is visible. Kinetic. Maybe for those who are writing at home, let me give you the best spelling. I think you can be able to see. Kinetic energy. So these are the energy that we are going to discuss today. How will this energy, maybe light, be transformed into another energy? That is what we are going to discuss about energy transformation. So the forms of energy class, we have the light energy, we have the heat energy, we have the magnetic energy, we have the electricity or electric energy, we have the sound energy, we have chemical energy, we have mechanical or kinetic energy. When I talk about mechanical, these are machines that is in motion. Kinetic is the energy in motion. Then we have the potential energy, energy at rest. So all these are the types of energy that I'm going to take you through one by one, so you understand how this energy can be transformed from one form to another, or it can be converted from one form to another. That is what I want you to understand. Then, after that, leave that aside. I want now to define what is energy transformation. Energy transformation is the change of energy from one form to another form. This is the change of energy from one form of energy to another form of energy. Another form of energy. That is what we mean by energy transformation. This is the change of energy from one form of energy to another form of energy. What are those forms of energy that I'm talking about? These are the form of energy. How will the light change into heat? How will the heat change into electricity? How will the sound change into another chemical, and all that and all that? So these are the forms of energy that I'm talking about here. Then one thing that I want you to know, class, that energy cannot be destroyed nor created. Energy can neither be created nor destroyed. Energy can neither be created nor destroyed. That is the law of energy conservation. That is the law of energy conservation. But energy can be transformed from one form to another. I want also to understand that when you talk about the light, it's a form of energy. But light energy can be reflected. Light energy can be reflected. Light energy can be refracted. And light energy can also be dispersed. So when we talk about light energy, can be done in so many ways. But when you talk about the holistic arrangement of the form of energy, energy cannot be destroyed nor be created. You cannot create energy. You cannot destroy energy. And I hope by understanding that one, you can be able to get this topic well. Now, let me take you through this. Light energy. Light energy as our number one. Light energy. I want to say that the main source of light and heat on planet Earth, the main source is what we call the sun. Sun is the main source. Sun is the main source. Get that one. Sun is the main source of energy on planet Earth. So the key thing that you are supposed to know, what gives us light and what gives us heat as the main, is what you call the light energy. So that light energy is what we wonder. How is this light energy being transformed from light into another form, into another form, into another form, and all of that? That is something that I want you also to understand. Then, number two, I'll just take you through them. Number two, we have the heat energy. Heat energy. Heat assists us to do so many things which the light cannot do. Light enables us to see. When there is the sun, when there is a bulb, or when there is a torch or a lamp, we can be able to see. But when there is heat, at times, heat is not used for seeing or taking a photograph like the light. Or light is used in so many things where the heat is limited. Heat is used for cooking. Heat is used for warming. Heat is used for burning things. But light is used for seeing, it's used for photograph, and also light can as well be used for photosynthesis, the process by which green plants manufacture their own food in the presence of light and other factors. Then, number 3, we have magnetic. Magnetic energy. Magnetic energy. This is the form of energy. This is the form of energy where the magnetic materials attract each other. When brought together, they do attract. And these magnetic materials have the force. And of course, they have the poles. Maybe if I just take you through this. If this is a bar magnet, you'll have to find that one side of a magnet is north and the other side is south. So we have the north pole and the south pole. So when there is also another magnet, and this one maybe it is south and this one is north. Of course, you are going to find that when you take these two magnets close together, it might attract or repel depending on which poles are you pointing to. When it is south and south, the like poles repel and like poles attract. When you take this one and this one, of course they are going to attract. But when you take north and north, they are going to repel. When you take south and south, they are going to repel. For example, when I join these two magnets, this is north, south. This is south, north. What will happen to this magnet? They are going to repel to each other because that is the force that will make them to move apart. But when I join this one, there are two magnets here. This is north, south, and this is north, south. These two magnets are going to attract because these two are unlike poles. But these two are the like poles. The like poles repel and like poles attract. Then there is also another part that I want you to know on electrical energy. Electrical energy. Electrical energy, I want to tell you this. Electrical energy, this is the form of energy that is moved through the wire. We must have a transmitter. We must have a form of media. But these two, light and heat, does not need media. But magnetic need a media. It must be a metal, and that metal should be magnetic materials. We have electric energy, which will only move through the wire or through a metal. That is what I want you to understand. This electrical energy, it requires a media for it to be transferred from one form to another. Then we have number 5, which is sound energy. The word sound is only produced when an object vibrates. For example, that is sound. Of course, that sound is going to come out. For you to hear that sound, it must originate from a point, and then it vibrates into different parts and all that and all that. So for you to understand, or for you to get this, you must know that a sound can only be produced when an object vibrates from one point to another. Then, chemical energy. Chemical energy. Chemical energy is the energy which is stored. This is the stored energy. This is what you call the chemical energy. It is also called stored energy. Stored energy. Energy which is stored is called chemical. It is mostly found in fuel. It can be found in food. Of course, fuel, if I talk about fuel, I'm talking about firewood, I'm talking about kerosene, I'm talking about petrol, I'm talking about diesel and all that. Then this is what you call the stored energy. Can only work when it's released. When it's released from their original form. That is when it can now become in use. Then we have mechanical energy. Mechanical energy, it includes motion. Mechanical. Number 7, mechanical. Mechanical energy is the energy in motion. That is why I use the word kinetic to demonstrate that kinetic is the energy in motion. That is mechanical energy. It's when the dynamo or the engines are moving. It's when you can now see that mechanical is being used. That mechanical energy is also called kinetic energy, and in short, we can as well say energy in motion or energy in movement. So potential energy, this is the energy at rest. Potential energy is the energy at rest. Potential energy. This is the energy at rest. Now, you have now understand what are the forms of energy, and you can be able to define in short what are these forms of energy, how are they going to be used, and where do they originate from. Now, I want to take you examples of energy transformation. Examples of energy transformation. Examples of energy transformation. So earlier, I defined the word energy transformation as the change of energy from one form to another. That is what you are supposed to understand, that energy transformation is the change of energy from one form to another. Then we want to see how this energy will be transformed. Let me use a simple circuit. Simple circuit. So in a simple circuit, I will tell you that a simple circuit has just some few components which are main. Simple circuit. First, the word circuit, maybe you can write down something. The word circuit, this is the path followed by electricity. A circuit is the path followed by the electricity. That is what you call circuit. Circuit is the path followed by electricity. Path followed by electricity. That is what you call a circuit. Then a simple circuit has the following. 1, the dry cell or the battery. Let me use the dry cell. 2, it has the bulb, or you can use the ammeter. Number 3, it has the wire. Then number 4, it must have a switch. a switch. So these are the main components of a simple circuit: the dry cell, the bulb, the wire, and the switch. Now let us connect and see the energy transformation there. First, I want to connect for you. Let me draw it. This is how it is drawn. Assume that this is the bulb. No, this is the dry cell. Let me use one dry cell. This is the positive terminal and this is the negative terminal. Then this is the wire. That is the wire. It is connecting from one end to the other end. Then this one is the bulb. This is the bulb. To me, draw it properly. This is the bulb. Then if you check that connection of mine, it is wrong. Of course, this wire should connect into this part, and then this one connect on the other side, because this one also has negative and positive. So this one is going to touch here. So this one, that one is what you call complete circuit. Why am I drawing complete circuit? Because a complete circuit, it is the only place where we can see energy transformation. When the circuit is not complete, you cannot be able to identify or see energy transformation. So I've drawn this one to show that the energy is being moved from this one to this part until the end. But there is a place where we can as well have a switch. So this, in this part, that is my switch. If you connect this one, you will make it complete, incomplete. So this one is what you call incomplete circuit. Incomplete circuit. But complete is when the path or the electricity is going to flow from the first one to this one up to the last. This part, it is the chemical energy. Chemical energy is the energy in store. It can be found in dry cells, in batteries. It can be found in fuel, in fruits. It can as well be found in firewood and all that. So this one is electrical energy, energy in wire, electrical energy. Then this one is, of course, the energy which you can be able to see. That is the light energy and the heat. We first start with the heat, then light. So where there is heat, of course, light is going to be seen. Then when I want to draw energy transformation here, we start with the chemical energy. We go to, chemical energy. We go to electrical energy. The next one, yes. The next one, it is going to be heat energy. Then lastly, light energy. That is what you are supposed to know and what you are supposed to indicate when you are given such like questions. Let us carry out an experiment. So this is the bulb. This is the bulb. This is the bulb. This is the wire. The wire. This is the wire. Then of course I'm going to take my batteries from the torch. Let me open. Observe here, you can carry out your own experiment at home. So these are the two dry cells. The dry cell is called dry because they don't have acid in it. But when I use the battery, it is called the lead acid accumulator. That is the one that you can as well put the acid inside, which has the stored energy, which is called the chemical. This one also has the chemical energy. the dry cell has the chemical energy. So we have the negative terminal, and this is the positive terminal. The one that protrudes outside is the positive, and the one that maybe it's flat, it is negative. So I'm going to use the positive part. It's attached to the positive negative. Then I hold it in this manner. Then I take my wire. I make sure that one side of the terminal touches the wire and the other side touches here. That one, it is complete circuit. But now how will you know that there is flow of energy? Because there is no ammeter, there is no an indicator to show that the light or the heat is moving through the wire. It's very bad to test using your mouth, very hazardous. What you are going to do, use the ammeter. Use the bulb, put it here, then you can be able to see. That is what you call complete circuit. The flow of energy from the bulb, the flow of energy from the dry cell to the wire and to the bulb, from chemical, electrical, and light. But before you reach into that light, there is heat. Let me hold it properly for you to see. Good. I hope you can be able to see. Wait a minute. Good. Wait a minute. I make it properly. Chemical energy, electrical energy, heat energy, light energy. Carry out the experiments at home at your own disposal time, and you're going to enjoy it. When it comes, get the answer right. Thank you. So I also want to demonstrate for you, maybe for you to see. It is here. Let me give you. If you can be able to see this energy transformation, I've drawn here energy transformation. We have the wire, we have the battery, which is a dry cell, we have the switch, then we have the bulb, which it's going to indicate that there is flow of energy that moves from one form to another. Let me indicate that one for you to know that it is lighting. So this energy, it starts with chemical, electrical, heat and light. Chemical, electrical, heat and light. That's the procedure that you are supposed to know when you want to make a simple circuit. The dry cell, the bulb, the wire, and the switch. Those are the components. But the energy transformation, chemical, electrical, then heat, then light. Thank you. So we want to move to another energy transformation, which is called burning the fuel. When a fuel burns, or a fire, let me take the fuel to be the firewood. This is the firewood. We assume this is the firewood. This firewood will have to change from one form to another only when it is burned. So this burning will have to change the chemical energy, which is the energy in the store, chemical energy, let me write here, which is already stored, into heat energy, then into light energy when you are given the firewood. This is the energy transformation. Sorry. This is the energy transformation. Let me take a glass of water. That is the energy, thank you, energy transformation from chemical, heat, and light. Now, I also want to take you through another form of energy transformation. This energy transformation that I want to take you through, it is the burning candle. Burning candle. A candle has the stored energy. It is a fuel. So this is the candle. This is my candle. Of course, it's full. I want to put it here and demonstrate for you. A burning candle. To me, light. Don't shy. It's not going to burn you. It's away from you. This is the candle burning. Just a moment. I show you. Yeah, it is now standing. So this candle, it has the stored energy which is called chemical. The chemical energy is being burned. For it to be realized, or for the one form of energy to be transformed from one form to another, it must be released. Now I've released it by lighting using a matchbox. And as you noticed earlier, I used a matchbox. Still that matchbox has chemical energy. When I strike it, it is mechanical, striking, mechanical, or energy in motion, that is kinetic. Then it goes to heat, then light. Striking a matchbox, and also lighting. There are two energy being transformed here. So let us see here. This is a candle. We'll start with the chemical energy. Then we go to heat energy. Then you go to light energy. That is energy transformation in a burning candle. In a burning candle. When a candle burns, that is the energy transformation that you are supposed to observe. Chemical, heat, and light. Of course, it is here. You can be able to see. Although carry out an experiment under the supervision of a person whom you know that can guide you well. Unless if you want to burn the house. Thank you. It is off, although there is some smoke being released. Let me put it here. Then there is another energy transformation that I want to carry out. Another energy transformation that you want to carry out. A radio. Energy transformation in a radio. The energy transformation in a radio, we first know that a radio that uses dry cell will have to produce the sound at the end of it when switched on. So we assume that this is my radio. Let me see if I have it here. Have it here. This is the radio. When you turn the radio on using this knob, you turn it on, then let us see the energy transformation that is going to move. The first one, it has the dry cell, which is chemical. Then it will have to go to electrical through the wire. Of course, it is going to go to magnet because there is a magnet which has the speaker that produces the sound. A magnet, I'm using the word magnet because you have the speaker inside the radio. Then we have mechanical, because for that magnet to release the sound, there is that motion, there is that beat. So we have the mechanical or kinetic, then you have the sound. Chemical energy, let me use the initial. Electrical energy, then we have not electrical but magnetic energy, chemical energy, electrical energy, energy in wires. Then we have mechanical energy, then we have magnetic energy, then we have mechanical energy, then last we have sound energy. Let me take you through for this for you to understand. We have chemical energy, the energy in dry cell. We have electrical energy, the energy that is in wire. we have, this one is called magnetic energy. That is the energy in a magnet. Then we have mechanical energy, because there is that movement of the speaker. Then we have the sound energy, which you can listen to a very good music. So that is the energy transformation in a radio. I want to give you an assignment so that you're also going to tell me when I come back next time, what will be the energy transformation from the broadcasting station to a radio. So that is something that you'll have to go. What is the energy transformation from the broadcasting house? From the KUTV, these are broadcasting. What will be the energy transformation into your radio that uses dry cell? Thank you. Then there is what you call energy transformation in a bicycle dynamo. Let us see bicycle dynamo. A bicycle dynamo. What is the energy transformation in a bicycle dynamo? In a bicycle dynamo has a knob that rotates. A bicycle dynamo, in fact, I want you to understand this. A bicycle dynamo do not have stored energy or chemical energy. So do not start with the chemical energy when you are stating or explaining the energy transformation in a bicycle dynamo. Energy transformation in a bicycle dynamo starts with the first one, the rotation of that knob. That is kinetic. The knob is just like this. Then within this knob it has wires. So this knob must be attached to a wheel which rotates. But let me check for you to see. This here, the energy transformation. This is the bicycle dynamo. Then this is the wheel. Then this is the knob. This is the dynamo itself. This is the terminals. Then this is the wire. So we have the kinetic, the energy in motion. Then we have the mechanical. Mechanical energy is the energy, I said the mechanical is the same as kinetic, which is moving, the mechanical energy. Then we have this one, magnetic. Then we have electrical, we have heat, and then we have light. So this is something that you are supposed to know and state the energy transformation in a bicycle dynamo. It starts with this one, which is kinetic. Kinetic. Where is this kinetic? Kinetic is the rotation of the wheel. I want to mark that one. Kinetic is the rotation of the wheel. Then from when the wheel rotates, after the wheel is rotating, it goes to the mechanical, because this is now the knob. There is some mechanical that is going on, because from the kinetic you go to mechanical energy. After going to mechanical energy, we go to magnetic, because there is a small magnet which is found here. A small magnet is found in the bicycle dynamo. Magnetic. From magnetic, you go to heat. No. Electrical, because there is a wire here. Electrical energy. From electrical, you go to what you call the heat. Then you go to light. Of course, you are going to use that one to light the way, or to light the rod as you cycle. Let me show you how it is. So this is the bulb. So this is the bicycle dynamo. It is trying to rotate on this wheel as you drive, and it can only produce the light when this knob is rotating. When it's not rotating, there is no way light is going to be seen. So this is the bicycle dynamo. We start from kinetic, the rotation of the wheel. We go to mechanical, because mechanical, I said, is the energy in motion, and there is some mechanism going on there. Then we have a magnet. There is a small magnet which will have to make this part being attracted. Then we have the electrical, the energy in wire. Then we have the heat. Then we have the light, which you can be able to see with the yellow color. Thank you. Then I want you to take you also through, there is a small part. When you strike a matchbox, I said when you strike a matchbox, I have it here, to me demonstrate. These are stick, these are matchbox. This one has the dark part on the other end. That part is chemical. It has the chemical energy. This is the wood, the chemical energy. The chemical energy is the energy which is stored. So we'll start with the chemical. As you strike, there is mechanical going on, or there is kinetic going on. Strike it like this. So once I have struck it, there is what you call chemical energy. Then I'm striking it here. There is that kinetic energy, the energy in motion. Then there is heat, then there is light. When you are striking a matchstick. Then we have another form of energy, the energy in a rolling stone. A rolling stone. Maybe let me draw this. The stone is here, and then this stone is released. You are releasing the stone. This stone itself, it is at rest. So it has what you call potential energy. Potential energy. When it's released, it rolls down. Maybe it's here. It is now in motion. Kinetic energy. Then it will stop somewhere here. It is called potential, kinetic potential. That is the energy transformation in a rolling stone. You can as well even use a pendulum. A pendulum, let me draw it here for you to see it properly. Let me rub here. Pendulum is here. That is pendulum. Or you can draw this one. Then this one. You release it. It is going to move from point A to point B. So from point A, it is potential. Then here, it cannot stand here because it is in motion. It is going. So from point A, it's potential. From point O, it is kinetic, then potential. It will rest here for a moment, then come back. So it will keep on swinging. This is an experiment that you can use at home, at your own free time, to carry out and observe how it is working. But you need to know how energy is being transformed from one form to another. Then we can as well use a person running. When you run, that person, which energy transformation is that? For example, the person has chemical energy. The person has, because you are running using the energy inside you. But this stone, I used the word potential because it must be pushed by something. But this, I'm the one who is running. So I have the chemical energy, then kinetic energy, then I'll have to release heat, but I'll not release light. Because the heat, it's due to that mechanical process that takes place in the body. So we have the chemical energy, then the kinetic energy, then as I move on, it is going to go to heat energy. Because you are going to see the sweat, and of course, the body temperature will rise. So you can go on and go on and go on, even using a catapult, just like a V. Sorry, it is a V shaped. Then this one. So when you stretch it, it's going to release this tone. So it is in potential, then kinetic, then it will drop to potential. That is using a catapult. I hope you can go on and go on. Even using HEP, hydroelectric power, how the power is being trickled from the dam. The dam, that is the moving water. The dam, remember the dam, the moving water is stored. That is the energy at rest, potential. Then it is moving to kinetic. Then it goes to, of course, to the turbines. It turns mechanical. When the turbines turns mechanical, then it goes to electrical. Then from the electrical, it goes to heat, then light. You can be able to see the light in the house because of that energy transformation. You can do it more practice on that. Now, there is some vital part that I want you to know. That is the part of KCPE. How are the questions have been being set? Maybe I'll take samples of some few questions and give you for you to understand that these things is real. For example, in 2005, there is a question that was brought. Let me take you through. In 2000, the question reads, which one is the energy transformation that takes place when a radio that uses dry cell is in operation? Question 5, 2005. We'll start with the chemical, then a radio that uses dry cell. You'll go to electrical, you'll go to magnetic, you'll go to kinetic, then you'll go to sound. That is the best. Unless that radio has a sensor, a light, then it will be heat and light. Then 2006. Which of the following source of energy does not contain chemical? Number 33, 2006. Car battery, bicycle dynamo, food, and firewood. Of course, which one does not? Automatically it's going to be a bicycle dynamo, because I said a bicycle dynamo must be attached to a rotation or a rotating wheel. 2007, see how it's going. In which of the following groups of sources of energy only contains chemical energy? Question 31. Charcoal, dynamo, kerosene, dry cell, firewood, food, and all that. Of course, it's going to be charcoal, kerosene, and food. It is the one that contains chemical energy. It goes like that, it goes like that, it goes like that, like that. Then, if you go to other questions, of course, 2018, they also asked a question in that manner. They can ask you the question maybe to define ability to do work. What is it? That is energy. So the questions on energy transformation, I tell you, you can't miss. You can't miss a question on energy transformation. I want you to take note of that, do more practice, and if there is any questions pertaining the energy transformation, you can be able to send the questions on the WhatsApp number that is being portrayed down there, and then we can be able to answer the questions accordingly. If you have the comment or compliment, you are free to send and take it back to us. Thank you for listening, and thank you for tuning in KUTV, and let us meet next time. Remember to stay at home and stay safe. Thank you, and God bless you.